represents the lengths √2, √3, √4 and so on respectively. Representation of real numbers on the number line through successive magnification. Visualize 3.765 on a number line using successive magnification. We know that 3.765 lies between the interval 3 and 4. To have a rough idea for locating it on a number line, make 10 equal parts and mark them as 3, 3.1, 3.2 and so on up to 4 as shown. Now look the portion in between 3.7 and 3.8 using magnifying glass and realize that 3.765 lies between 3.7 and 3.8 as shown in figure 1. So, let us now divide this portion into 10 equal parts and represent them as 3.71, 3.72, so on 3.8 as shown in figure 2. As before, now we can visualize through the magnifying glass that 3.765 lies in between 3.76 and 3.77. So, let us focus on this portion of number line as shown in figure 3 and imagine to divide it again into 10 equal parts. Thus magnify it to see it better as in figure 3. This is how the terminating decimal expansion on a number line is represented. Now, let us represent non-terminating recurring decimal on a number line. Visualize 4.26 bar on a number line using successive magnification. Here, the repeating decimal 4.26 lies between the interval 4 and 5. To have a rough idea for locating it on a number line, make 10 equal parts and mark them as 4.1, 4.2, so on up to 5 as shown in figure 1. Now, look the portion in between 4.2 and 4.3 using magnifying glass and realize that 4.26 lies between them as shown in figure 2. So, let us now divide this portion into 10 equal parts and represent them as 4.26, 4.261, so on up to 4.27 as shown in figure 3. As before, now we can visualize through the magnifying glass that 4.2626 lies in between 4.262 and 4.263. We can proceed endlessly in this manner and simultaneously imagine the decrease in the length of the interval in which 4.26 bar is located. Operations on real